Limitless amoebocyte lysate, or LAL, is the product derived from horseshoe crabs' blood in order to test pharmaceuticals and injectable devices for endotoxins. In the presence of endotoxins, a horseshoe crab's hemolymph will coagulate, rendering any pathogen that would cause them harm immobile. When observed in laboratories, this reaction alerts scientists to contamination, which would make us sick if allowed to enter our bloodstreams. LAL is the topic of some major scientific and conservation discourse. With so many stakeholders involved and differing opinions surrounding the sustainability of harvesting horseshoe crabs, it can be difficult to know who's right, especially with so many misconceptions circulating. That's what I'll focus on in this video. I will identify misconceptions regarding horseshoe crabs in this debate and explain, with supportive evidence of course, why they're incorrect, or at least oversimplifications of the full picture. Number 1. It's their fault. When it comes to the conservation of horseshoe crabs, it seems like everyone's got someone else to blame. The biomedical companies say, hey, we catch and release. We're not the problem. The bait industry points the finger at them and says, they take the crabs too. Why are we getting all the heat? And environmental groups, they're often stuck in the middle, trying to hold both sides accountable. But sometimes, even they simplify the issue. The truth is, it's complicated. Yes, biomedical companies do practice catch and release. They don't kill the crabs outright. However, while the crabs may be physically returned to the ocean, they're not always the same when they get back. We'll discuss this more later. On the other hand, the bait industry is undeniably responsible for the majority of horseshoe crab deaths. These crabs are used to bait eels and whelks, two fisheries with real market demand. It's a direct loss of life, and it adds up fast. But here's the thing. The fishermen who collect these crabs aren't villains. Many of them are working under state-approved contracts. This is their livelihood. Simply vilifying them or cutting them out of the conversation doesn't help the crabs, and it certainly doesn't lead to solutions. If anything, it just closes the door on a group that could be a powerful conservation ally. What we really need is a shared plan, one that includes biomedical companies, the bait industry, scientists, and conservationists, one built on cooperation and accountability, not finger-pointing. Because if we want to protect horseshoe crabs for the long haul, we're going to have to work together while recognizing that everyone has room to improve. Number 2. The ASMFC has failed horseshoe crabs. Another group that gets a fair bit of heat in the horseshoe crab conversation is the Atlantic States Marine Fisheries Commission, or ASMFC for short. Critics say that the ASMFC has failed to protect horseshoe crabs through effective regulation, that they've let overharvesting continue, or that they're too lenient with the industries involved. But let's unpack that. ASMFC does play a central role in managing horseshoe crab populations along the U.S. Atlantic coast. They've developed conservation guidelines, harvest quotas, and best management practices. In short, they've written the playbook. But here's the kicker. They don't actually have enforcement power. The ASMFC can recommend policies, but they can't make states or industries follow them. They can't hand out fines, revoke licenses, or penalize companies for noncompliance. They're more like referees, without the whistles. So when it comes to holding bad actors accountable, their hands are kind of tied. If we want these conservation rules to have teeth, we need to give the ASMFC some actual bite. That means policy changes, giving them the authority to financially penalize groups that don't follow the rules. Number 3. Biomedical companies are just lazy. One critique you might hear about biomedical companies is that they're just lazy. They could have switched to a synthetic alternative to LAL years ago, but they just don't want to. But again, it's not quite that simple. Yes, there is a synthetic alternative to LAL. It's called recombinant factor C, or RFC for short. It's made without using horseshoe crab blood at all, and it's been around for a while now. Sounds like an easy win for conservation, right? So why hasn't everyone switched? Well, for starters, it's not up to the companies. The U.S. Food and Drug Administration is the agency that regulates and approves how drugs and medical devices are tested for contamination. That includes what kind of endotoxin test is acceptable. And in many cases, the FDA still requires the use of traditional animal-derived LAL. So while some companies have adopted RFC voluntarily for certain products, others are legally required to stick with the old method. It's not just about motivation, it's about regulation. But here's where things get interesting. The FDA can change its stance, but to do that, they need overwhelming scientific evidence showing that RFC is just as effective and reliable as LAL across a wide range of applications. And right now, that body of research is still growing. So if we're looking for a real call to action, we should focus on expanding the research. That kind of evidence is what can move the needle, and that's what could eventually reduce or even eliminate the biomedical industry's reliance on horseshoe crab blood. Number 4. Biomedical companies don't give back. Another hot take you might hear is that biomedical companies are just taking from the environment, harvesting horseshoe crabs for their blood without giving anything back. And sure, when you look at the surface, it's easy to feel like this is a one-sided relationship. These companies rely on horseshoe crabs to produce LAL. It's a product that literally supports the entire healthcare system. But what about the crabs? It's true that some companies haven't made significant public investments in horseshoe crab conservation, but this isn't the case for all of them. Some companies are trying to step up. Take Lonza, for example. They're one of the major players in the LAL market, and every year when Atlantic horseshoe crab breeding season begins, they host a conference focused on sustainability. It's a space where stakeholders across the industry come together to share updates, discuss best practices, and highlight innovations, like progress in synthetic alternatives. Is that enough? Maybe not. But it's a step in the right direction, and it shows that not every biomedical company is ignoring their role in this ecosystem. The bigger takeaway here is this: if companies are going to benefit from a natural resource, they need to be active participants in protecting it. That could mean funding conservation programs, supporting RFC research, collaborating with regulators, or just being more transparent about their practices. Number 5. Bleeding kills horseshoe crabs. I mentioned previously that biomedical companies do not kill horseshoe crabs in the same manner as the bait industry, but is the bleeding process entirely harmless? The belief that bleeding kills horseshoe crabs makes sense on the surface. After all, when we think about removing blood from a living animal, it sounds bad. And yes, bleeding can lead to death, but it's not the whole story. Studies have shown that bleeding alone, as in removing up to 30% of a horseshoe crab's blood volume, doesn't necessarily lead to high mortality. In fact, these animals are surprisingly resilient to the bleeding process itself. Horseshoe crabs have a natural ability to regenerate blood volume over time when in an aquatic environment. So, what's actually causing the deaths in some cases? More often than not, it's the stressors that come with the entire process: transportation, handling, time spent out of water, exposure to high temperatures, and crowding in holding tanks. Some studies suggest these environmental and logistical factors play a bigger role in mortality than the bleeding itself. There are a few outlier studies where researchers observed especially high mortality rates, and in those cases, the crabs had been exposed to multiple uncontrolled stressors. We're talking long periods without water, extreme heat, and rough handling. Basically, what not to do with a horseshoe crab. That's where the ASMFC's best management practices comes in. These guidelines recommend things like keeping crabs cool and moist during transportation, limiting how long they're held out of water, and reducing overall stress. When followed correctly, these practices dramatically lower mortality and behavioral side effects. If we focus on improving the full process from capture to release, we can make biomedical use of horseshoe crabs much safer and more sustainable. I hope this video has inspired you to research the conversation surrounding horseshoe crabs further. Maybe you think about them the next time you're getting routine blood work or a vaccine. Thank you so much for watching.